Hi everyone, good morning. This is Abhishek Wagh. I'm an organizer and AWS User Group Nashik leader. It's good to be back after a long break, but we are back again with very interesting topic for today's session, which is from APIs to AI agents, making serverless systems MCP native. So those who are following the current market trends already know that um, in AI ML world, MCP is the hottest buzzword right now. So that's why we have asked our speaker today to take this session on making serverless systems MCP native, because serverless and MCP go hand in hand, and which are most favorite topics from people who are also following AWS from a long time. So without a further ado, I will add Pushkar Thakur and I'll welcome him to the stage. So hi Pushkar, good
Hey
morning.
Abhishek. Hey Abhishek.
It's good to be back at AWS User Group Nashik, this time as a speaker. So
Yeah.
yeah, Pushkar, you can introduce yourself and the stage is all yours now.
Yeah. I'll shortly introduce myself. I work as a SG at Procedure Technology. I'm a AWS community builder from past 3 years. I work with Abhishek with the few community activities, and we do like interact with other communities also. So today's topic was like everyone is using AI at everywhere. Like in each of the aspect of the life is going with the AI. So we thought why not serverless also? So we can convert our lambdas, we can use them for the MCP native and we can convert them to MCP servers and they can directly talk to the AI models. So that way our workloads get easier. Is Abhishek screen share?
Yeah, definitely. I'll add your screen.
Yeah.
Yeah, so your screen is up.
Yeah, so we'll start this session. So from APIs to AI agents. So what is actually today's flow? Today's flow generally when user comes to the website or anywhere, the user comes on the front end, then clicks on something, then API gets it, API gets called to the backend, backend performs uh some operations or the that particular request that if there is some DB storage, like we have to store some data and all, so that happens, and then that response goes back to the user. That is how today's work. But with AI, everything changes. Like user comes, talks to the agent, then there are tools. Will go deep into the what are the exactly the tools. With the help of the tools, agents, with the help of the capabilities of the tools, agent can understand what to do, and then on the basis of that, it provides the outcomes, and that comes back to the user. So whole API and the backend that get abstracted with the AI agents. The the current problem with our APIs are not agent friendly. Like they are majorly built for the humans to consume by the humans. So whenever like agent needs some structure. So APIX we just and we expose the endpoint slash user slash profile and that we call and the other things happen in the backend on the server. But uh, agent needs proper clear intent. What agents can determine what function can't determine what function does or what when to call that particular function. It just gets a normal string that is like not able to understand. Another is poor semantics, like REST endpoint returns raw data, no context. Agent don't really like they are getting something, but they are not aware like what they are getting, why that is there, and there is no discoverability. As no standard way, the agent can go there and check what capabilities we have. So API requires human readable documentation. With the documentation flow, we integrate those APIs and use it, but agent needs machine readable schemas. So that these are three problems. So we are currently facing in our API system where we don't have the clear intent, we have pure semantics and no discoverable. So how the evolution happened? So we started with the normal structured backend endpoint via HTTP and endpoints. So normally we use the endpoint like slash profile slash me slash checkout, that kind of endpoint, and we consume those endpoint. But we need to maintain servers behind the scenes that handles everything. Then comes the serverless into picture. We just focus on the business logic rather than the how infra is managed. So serverless does have servers, but we don't have to manage. That's why it's serverless. So we just write a business logic where what should be done rather than how the whole infra should structure. So serverless handles that, so in that infra vanishes, only logic remains. Then comes the era three, that is the AI agents. Autonomous system that discovers, plans the things, call the tools on the requirement, like what requirements we have provided, and goes on complete that particular goal. So AI agents have a feedback loop at the end. Whatever the instruction we have given, with any way, with the help of the tools or the capabilities of the tools, they will complete the goal. So AI agents is more than just a model. Like if you think there is a model, there's set of the prompts are written and that way it is learning and moving forward. So that's not it. There's a under the hood, there are four major component that works. LLM, obviously, that it will need a reasoning engine that understand the intent, plans the actions, and generates the response. That will help with the LLM models. Tools that we'll discuss further. Tools are basically external capabilities to agent can call. So consider like many people must have used linear or heard linear. That is kind of a Jira, but better context. So ex- so if we want to access that particular linear, so there should be some layer that can be introduced. So that way, with the help of that tool, you can access the linear. So that way, external capabilities for the agent can call API function, database services, everything. But when we talk with the agents, there should be like with the human, what happens? Human, whenever there is conversation after even a month we met, like we recall, okay, what we had a conversation last time. If that person forgot anything and you have to repeat each time you met, that doesn't a conversation. That doesn't feel natural. So same with AI agents. It has a short and long-term context that continues across the multi-step tasks. So if there is a, we have to complete four tasks. So user logs in, user do some, user place the orders, then checks the profile. So if want to automate that kind of thing, so there should be context key. Okay, user is logged in, then we have to do this, then do this. So they need the context of the previous task. So that goes in the short-term context. A large-term context goes overall. They say many people, like I also chat a lot with the Claude GPT, and they know many things about me. So it has the overall context about me, ki what I do, how I work, my the way I work, my habits, those goes in the long-term context. So that helps to get better response generation. And there is a planning. Many people miss this phase. Planning does help a lot when you like talk with AI agents. If you know, like if AI agents have the clear instructions or a goal or the steps they have to follow, that way they can produce a better result than anything. So how that whole MCP architecture look like? So at the first layer, there will be the agent, the user we are talking, the LLM power architecture. So it decide which tool we have to call, and the based on the like we have the five set of tools. We won't go there like call all the tools and see who gives the better answer. No. So we provide some prompt on the basis of the user prompt. It understands okay what tools we should call, so that does the agent part. Then MCP comes the MCP layer. So MCP layer that translate the whole what agents want to say into the structure format. So tool like full proper schema majorly in JSON that helps to understand it. It converts the intent. Then tools. Currently in our case, the tools are serverless functions as the MCP tools. So I have a demo up in this session also. So that way I'll explain how to convert the parse serverless function into the MCP tools. So tools are serverless function in our case, and it can be anything. register MCP, each tool is type described. We have mentioned a set of instruction in that Lambda function. So how that, like what should be done? So that does that. And after that Lambda function calls to the DB and performs the set of operation and come back to the agent with the response. So how is the, like how build, like if you're building something that should last forever, like not forever, but like last at least some point. Like if you are change, we need to change the things each day. That doesn't make sense. So basic design principle should be intent based. Like tools describe what they do, not how. Agent can select by goals, implement by goals, not implementation details. So intent should be clear, like what we have to do, and tools will describe like what they do rather than how they do it. So if someone is saying I play cricket, so you won't ask him like, how you play it. It will be like, okay, you play cricket. If I need a cricketer, I will talk to that particular person. So that's kind of thing. Schema first. Every input and every output should be tightly described. No, like you assume kind of things should not be there. It should be like if I provide this output, this should be the like this input, this should be the output. Tools are independent engine. Agent change freely without coupling or shared state. So agent has their, like we should not couple a tool with that particular agent. Like same tool can be used by the other LLM models, such as like some same. Just a linear has a MCP, so Claude can use it, ChatGPT can use it. So any model can use that particular MCP. So that's why that they are independent units. Deterministic approach. So same input, same output. It should be predictable. So that way, like if something is happening, if I'm okay, so consider a linear example again because I use it daily. That's why explaining them with the same tool. So with linear, if like linear MCP, I provide assign that ticket to me. So I know that ticket output will be the ticket is assigned to me. So yeah, that is it. Same input, same output should be there. Okay, so serverless as a tool, so we will use a Lambda function as a tool. Every Lambda function exposes define action, and agent can expose like agent can invoke that action from our command. We don't have to rewrite the existing function. We can just wrap that whole thing under the like MCP tools. I'll show how to do it. So that way we don't have to write everything we have written. Agent composes, agent sequences, how like that sequence should be done, and if something fails, it will retry that again, retry with that tool. If it works, it will go forward. So let's go to demo rather than just uh, talking about AI agents and everything. So demo, we have expense tracker. So with the AI agents that we will talk to the our database that manages our expenses. So for the demo, I would like to save our time. I already created a table named expenses. Okay. Uh, okay, just give me a minute. We'll sign- Okay. Yeah. So we are into the expenses table. So it has few data that I have already added. So it has user ID, expense ID, amount, how much amount we have like spent over there as an expenses category. We should look in which category we have, description, and the basic created and updated at fields. So these are users, these are expenses ID that I have created. Yeah. So to talk to this DB, okay. Yeah. So talk to do DB, I have created three Lambda functions. So one function adds the expenses, One function provides the monthly summary, and another function that categorizes the particular expense as food, transport, medical bills, that kind of. So we'll just show this function. Yeah. So it's a normal function as we wrote. It's a very basic one that accepts the some parameters, throws the error if there is a bad request and all. So main thing is that just this, we have for loop that it iterates with the categories and just concat everything and as the amount and returns the response to us. These are like it's a simple demo. I haven't added anything complex. This is our add expenses. So whenever user sends any kind of expenses like that, they will prompt the thing, will break it down, and AI will break it down. From that, that will pick. It will call invoke this add expense function, and they will add the details. So user ID expenses, and this function will add into the table. Table name is our expense table. There is another function categorize expense. So we have three categories like food, transport, entertainment, other categories. If it's not one of them, if the keyword is not one of them, we can just add to the miscellaneous. Otherwise, it will add to the particular categories. So those are function. I have exposed this function with the function URL to our agent. You can use Route 16, uh, Route 56. So that with that you can expose those. But for the sake of demo, I have just added a functional URL. Let's go back to our code editor. So yeah, file structure. Yeah, so we have three basic files. One that agent file, another is the execution file that checks like what is the particular category and which function we need to execute. And there is a tools file that is converts the like it's considered as a wrapper that converts our like builds our MCP server. So name is category expenses, basic description in that we added a parameter and it is a required field. So if there is something missing, it will throw an error. So we have just mentioned what parameters that art expense will get, get monthly summary will get, and the category expenses will get. So flow goes, I have simulated here a agent. I can show, yeah. So in this file, it is using the OpenAI. So OpenAI, we need to provide the key. You can like go to the OpenAI slash developer, I guess, or key. So that way they will provide you the key. So here is a user input. User input that is specifically you can consider as a prompt. If you it is a prompt. If you provide the text input, user will be enter something like this. So that goes there. So message has a two field that is role and content. Content is obviously the user input. Role is who's the person who's adding that. We are using GPT 4o mini that serves token. So yeah, so it goes calls it like then removes the function like what is the name of the function, what are the arguments. So here we are like added and show in my summary. So we are seeing added. So with AI, it understands add it means we going to add that expense. For adding that expense, we will need which function? Here, add expense function. So add expense function has a few arguments. Yeah, so user ID, amount, category, description. So those are the arguments. It takes it, then calls the particular lambda function and provides us the response. So I'll just show, like I haven't added the API key. So I have simulated the similar flow here. So here is like I spent 200 on taxi. Let's consider I spent 100 rupees on taxi. So description is taxi ride. I'll just run this. Okay. Mm. Where is our DB? Yeah, here is our DB. So DB has currently three expenses. Two is the food, one is transport, 500, 500, 200. So we'll just run this file. So this is categorized expenses. Agent says categorize expenses, then category it understands transport. Then it goes like stage two is we need to add expenses. Then agent says this is thought process. It's saying adding expenses. Then we are saying ki show us the result summary. So this is the final result where today's date, total how much we have spent, and how like how the split for the per each category. So we have total four. Previously it was three. So food 1,000 rupees, transport 300 rupees. If we can refresh here, wait, my dynamic. Okay, explore tables. Yeah, we have four expenses. That is last one is 100. We are just added. So that way, like user just provided this command, and from that, like LLM, like AI agent talk to the our Lambda functions. It chose on the basis of what we have provided. So these are tools for the AI agent. So whatever like it chose from the command like prompt what tools that need to be called. So for adding expenses, the tool was add expense. So it went like it knows what add expenses do. It's adds. So that's why it calls add expenses. Then we last one was get or and add expenses, and then we also need to categorize that particular expense. So we call the categorize expense, and after that we ask for the monthly summary. So it provided the month and the total summary. So it calls all the three function, but just the different order as they need it. First add expenses, category expenses, then get monthly summary. Okay, that was it for the demo. I have like posted this on the GitHub. It's a small basic demo, so you can check it out. Abhishek can like he will put a link in the comments. So we have security like built in. So each tool operate with minimum permission. We have in the Lambda we have provided the what is that permissions? Yeah, we have provided a specific role only like we have provided the role for accessing the DynamoDB, and there are five actions we have provided to it. Yeah, allow DynamoDB get ops. So without like only this action that particular function can do. So we are not going outside the scope. So input validation always happens if there is a something wrong is going. MCP layer will like if user provided something that we don't do. Like if there is adding expenses, get server expenses, but there is something like delete expense. We are not doing that. So that it will reject at the that particular layer only. Guardrails, hard boundaries, like what agents can do or cannot do. So we cannot like we have provided three function access. After that, there is no delete. So cannot delete from the database. So that provides accidental delete by the AI agents. So observability, like how that is like one of the things how we observe. Like in normally we go through the logs, what is happening that we knows. Like this function is getting called, this endpoint, after this endpoint, these are the things are happening. So In here, every tool call, like every invocation logged in with the inputs, outputs, and the latency, and the full audit trail by default. So whatever the so here I can show where is that? Yeah. So here it's mentioned like what function it is going to call. So we have the each function, how much time it takes, and everything. Debug. And there is a chain of thought that is this category expenses. So we have a small thing, that's why it is a just a small one line, and we simulated it. That's why it is like that. But it thinks properly, like what should be done. This is the thing. Then okay, this. So if you're solving some problems, you go okay. I have to solve the login issue. So what is the issue? So first you think in that way, then why like options like what are the causes like there might be three four causes from that there is a one cause which is because of that we are having the issue so we can while debugging or anything that will provide everything so if there is something we are missing we can debug from that and monitor if we need like track token consumption cost per task so you can from that you understand ki how much you are spending for particular task and how much that like if you're consuming too many tokens that doesn't like it doesn't solve your problem you're costing more money for the simple task so you need to optimize on that part and the so why MCP native serverless wins like what are the benefits that we get from that like why to do it so there is automation obviously agent completes complex tasks without like any human like we just provided a task like we provided a prompt it called all three functions and completed the task we and user can use that reusable obviously there is a and coding we have the dry principle so you just write once and don't and deploy everywhere like any tool built for one agent works across the agents instantly. So currently we have used OpenAI or you can use another agent. So that way it like you build one like you deploy that three we have deployed the three function once and any agent can access those so you don't have to recreate if the new agent comes in. Better DX schemas, no glued code. Like developer defines the interface, not integration wiring. You just see, okay, this is how I want. So and integration, AI agent handles. So less boilerplate, more capability. Like that helps. Okay, so it is a simple API. So everything is simple. Doesn't mean it doesn't mean a simpler system. So whenever you're debugging, agent failures are hard to reproduce. If there is a slight change of prompt, it will change the like how the process is going. So it's hard to pinpoint that the root cause. Every reasoning tips consume tokens. If you are using same like for new chart and you are not preserving context and we have to load the context again, that will add a significant cost in the token uses. Uh, that gets riled up too quickly if you're not careful, you're using a high-end model and you're not preserving context or managing context properly, it will eat up like that limit within just an hour or half an hour. Complexity, multiple tools which share context requires careful schema design. So that schema should be proper, how like one tool can talk to the other depending on the other tool. So if ad expense was there and there was a category expense so on that two it was like there is another one was get summary so on the output of these two the summary was depending but if something fails over there summary will also get like provide the wrong output at the end we will get the wrong output so complexity is high so future is like agent first is the next default. Okay, like browsers are agentic, mobiles are agentic, everything like we have Siri, Gemini. It is there. Then it was before also, but it's now more advanced, have more capabilities. Browsers like GPT has their own browser Atlas. DI is a browser by Arc. they have like browser company, they have built in AI in that. So agent replace manual UIs for the repetitive work. So if there is something happening, like if user like some person is coming doing this and this each every day, so that can be easily automated with the AI because it's a fixed set of the things that are happening. If you are adding tools like MCP servers that replace raw API, so how user communicates with your product that get changed. MCP becomes standard contract between agents and services. So I use I heavily use in day to MCPs, different MCP. Major MCP I use is the linear. So I hardly go there and create a ticket. I just talk to the agent. Agent creates the tickets. Agents moves the process, adds the artifact to the that ticket. So it's very easier. So like you don't have to think, okay, I have to build something big that only way. So it's like start with a single tool. Just build simple MCP, small scope, define a schema. Then with that, if you're like build one function, then add another function, then add another function. That way you will understand how design works and you will understand how things flows rather than just right like diving into that. Like if you add too many things, that will create the complexity. You won't understand anything. You will give up too early. So and AI is the future that everyone knows. So best to start take a baby steps and then build it. So we can just like if automate small things, then with the bunch of the small things you can automate the whole. Like if there are the big tasks, it always has the five subtasks. So automate those out of five, automate just one single task. From that, you can automate like from one to you can go to five. Once those fives are automated, automatically the one big task is automated. So yeah, if you have any question, you can reach out to me on LinkedIn. We have our meetup. Please join. We will have like more such session around the AI new technologies will coming up. So you please like join our meetup group. You can reach out to me on LinkedIn anytime. You can reach out to Abhishek or me on the meetup also. So yeah, thank you, Abhishek.
Hey, thanks so much, Pushkar, for the session. It was really insightful for me as well to know how we can easily use MCP native services using serverless. And as you mentioned, everyone should take baby steps to understand these things if they are beginner into this space. It was really insightful session, and thank you so much. Thanks for our participants as well who are watching this or will watch this later on YouTube. But thanks so much for turning up, and we are gonna definitely see you soon in similar sessions. And thank you once again, Pushkar, for sparing some time on the weekend. And
No worries.
yep, see you soon in the meetup.
Yeah, bye. Happy to be
Thank you
here.
so much, everyone. Yep.
Bye.